1.6 Algebraic manipulation with limits. So here we are working with more algebraic calculation of limits. So the first thing you want to do with any limit you have is try direct substitution. And by direct substitution, you see question 1. Limit as x approaches -1 of x squared plus 2x minus 4. Direct substitution just means you plug in -1 into all these values. So you get a -1 squared plus 2 times -1 minus 4. That is equal 1 minus 2 minus 4, and this gives you a -5. Question 2. Limit as x approaches 2 of 6. Well, there's nothing to plug in. It's just a 6, right? So the answer is just 6. You can think about this as like the limit as x approaches 2 of 6 plus 0x. So if you did like a 6 plus 0 times 2, you get 6. There's just no x, so you don't need to plug anything in. This next part here is called factoring and canceling. If we try direct substitution here, if you plugged in x equals 0 on the top and bottom, you'd get a 0 over 0. That's indeterminate, and that means we can factor something from the top and bottom. So if you recall algebra factoring, right? If you factored out the top, which is x times 4x minus 5, x times 4x is 4x squared, x times -5 is -5x, and on the bottom is still x, right? And then from here, you can see we can cancel out the x and the x. And then we're just left with limit as x approaches 0 of 4x minus 5. Now you can directly substitute this in. 4 times 0 minus 5, which is just -5. Here's another we're factoring one right here. Limit as x approaches -7 of 2x squared plus 13x minus 7 over x plus 7. If you recall your factoring for this problem here, be sure also you always rewrite the limit notation until you directly substitute the value in. So 2x squared plus 13x minus 7 can be factored out as x plus 7 times 2x minus 1 over x plus 7. You see right here, the x plus 7 on top and bottom cancels out. That's when you know you factor it correctly. And that's just equal to, or I'm not going to write that this time, limit as x approaches -7 of 2x minus 1. Now you can directly plug in -7 for x, which is -14 minus 1, and we get -15 right here. So factor and cancel, that's questions 3 and 4. So question 5, sometimes the limit might not exist. So for questions 1 and 2, direct substitution, you plug in the limit as, well, the x value is approaching, and you get a number out. Simple, right? For factoring canceling, you get 0 over 0. If you try direct substitution and then you have to factor to cancel something out on the top and bottom. For the limit not existing, you can see what happens if you plug in -6 here. If you do -6 squared plus 4 times -6 plus 3 over -6 plus 6. See, we're trying direct substitution first. -6 squared is 36 minus 24 plus 3 over 0. 36 minus 24 plus 3 is 15 over 0. This does not exist because you can't have a number divided by 0. That just doesn't work out. That's not how math works. So anytime you have tried direct substitution and you get a constant over 0, does not exist. However, if you get a 0 over a constant, that's fine. But if it's a constant divided by 0, you can't do that. So here are some special trig limits that you're going to have to just memorize for now. We will learn some tricks on how to calculate these later on, but for now, just write these down in the notes. Any limit in the format of sine x over x is equal to 1, positive 1, and limit as x approaches 0 of x over sine x, that's 1 as well. And the limit as x approaches 0 of 1 minus cosine x over x is 0, and this one here is 0 as well. These are just some special triglets you have to memorize for now, just for the purposes of, you'll see these examples down here. We can do some algebraic manipulation in order to help solve these problems. I'll show you an example. So you see limit as x approaches 0 of sine 3x over x. We're trying to make it something that looks like this top one here. So how we can manipulate this is, what we can do is multiply the top and the bottom of the fraction by 3. Because these are equivalent fractions, you can do that. All we're doing is multiplying the top and bottom by 3. So 3 sine of 3x over 3x. And what's nice about this, right? Sine of 3x over 3x, that's here. This one here, it's just instead of the x, it's 3x, but it's still equal to 1. This part, what I circled right here, is equal to 1. So 3 times 1, that gets us a limit of 3 right there. Nice and straightforward. So, this next question here, well, actually, before we move on, if you notice here, a little trick here. If you have sine of 3x over x, right, you notice a shortcut would just be, the answer is just the 3 there. Similarly, if you had like the limit as x approaches 0 of sine of 13x over x, it's just going to be equal to 13. So once you know that here, it can help you out with this limit problem here. So you can think about this limit as, let me see here, of sine of, oops, sorry. You can think about this limit as like the sine of 7x over sine of 9x. You can think about it as a sine of 7x, a sine of 7x over 1 times sine, not sine, I'm sorry, sine of 7x over 1 times 1 over sine of 9x, right? And if you multiply, because this is equivalent, sine of 7x over 1 times 1 over sine of 9x is what we have in the original problem here. And if you multiply the top and bottom by an x, so it's over x, like multiply the x on the top and bottom, you see we can use this identity from earlier, right? A sine 7x over 1x is just equal to 7 multiplied by, the limit as x approaches 0 of 1x over sine 9x, that's just 1/9. And that gives you 7/9. All right, so this last problem here, question 8, we have a cosine of x squared minus 1. This looks similar to the identity of, you have to remember this one. If you have an a squared minus b squared, that's equal to a plus b times a minus b. So this is like a cosine x squared minus 1 squared. So to factor out the top, what we do is cosine of x plus 1, cosine of x minus 1, over x of cosine x plus 1. And you can see if you do this correctly here, the cosine x plus 1 cancels out on the top and bottom. And then here you get the limit as x approaches 0 of cosine x minus 1 over x. And you see that's the same as this identity right here. So therefore, the answer to this question is just going to be 0. And you can circle that too. The answer is just 0 right there. If you have questions, please let your teacher know because there is a lot of some prerequisite skills from your previous classes that you need in order to be successful in this lesson. These skills will come up, so if you really don't get something, please, 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 I cannot stress how important it is to seek help now because this will help set you up for a foundation for the rest of calculus. Thank you.